Hello, this is my Physics 2212 Lab 6 presentation. The purpose of this lab is to observe and model the behavior of a magnet falling through an aluminum tube. We use Faraday's law and the PHYS law as our physical principles in this lab. We gathered physical data with a magnet setup and modeled the experiment in GlowScript. Results were that the experimental time was 0.682 seconds on average, and the simulated time through GlowScript was 0.592 seconds. PHYS law relates the magnetic field caused by a dipole to the magnetic moment of the dipole and the distance to the observation point. Using this equation, the magnetic field due to the falling bar magnet can be calculated at each instance in time. Faraday's law relates the EMF produced in a circuit to the number of coils and change in magnetic flux. Faraday's law notes that these occur in opposite directions. This is due to the induced current forming to oppose changes in magnetic flux. This formula allows us to calculate the current produced by the falling magnet at each delta in time. Experimental setup. System was the bar magnet and the aluminum foil tube. Surroundings were the earth. Components were the bar magnet, aluminum foil tube, a measuring stick, and a stopwatch. Initial conditions were that the tube had a length of 0.455 meters, an inner radius of 0.032 meters, and a width of 0.008 meters. In this experiment, we recorded the average time it took for a bar magnet to fall through the aluminum foil tube. This time was an average of 5 trials. We then recorded the length, outer radius, and the inner radius of the aluminum tube. Here's our GlowScript setup. Top left, we have the functions for our dipole magnetic field calculation and our change in flux function. In the bottom left, we have Faraday's law calculating our ring current. In the top right, we have the force due to the magnetic field setup, and in the bottom right, we have Newton's second law updating our position and velocity. Here's our results. In the top and just the left, we have the visualization of our bar magnet falling through the tube. We have a graph of velocity versus time, and then we can see that it took 0.592 seconds for the magnet to fall through. Some sources of error are inaccurate measurements, like of the tube, some roughness inside the aluminum tube, potentially making it slower than it should be, and some stopwatch delay due to human error. What if the tube resistivity were close to zero? How would the magnet dynamics change? If the resistivity was near zero, the resistance would be near zero. Therefore, the induced current would be much stronger, leading to a stronger magnetic force on the bar magnet. What if slots were cut in the tube? How would this affect the ring's current model? There would be less rings of induced current, meaning a smaller magnetic force. Therefore, the magnet would fall faster. Thank you for watching. Have a great day.